Okay, hello everyone. So today we're gonna talk about your periodic table. So in your periodic table, for the first thing you need to know is that elements will always be arranged according to their atomic number, meaning their proton number. Okay, the next thing here, okay, is that elements in the same group will always have the same number of valence electron. So if you do not know what is valence electron, it will be on the outermost shell. Okay, so the number of electrons on the outermost electron shell. Okay, because of this, they will also form ions of the same charge and they will have similar chemical properties. Okay, next, elements that is on the same period will have the same number of electron shells. So for just to clear up, if you do not know what's a period goes from left to right. Okay, so it's your horizontal rows, and then your groups are your vertical columns. Okay, other than that, metals are on the left hand side and non-metals are on the right hand side of the periodic table. Okay, so just make sure you know where to find the staircase. If not, let me show you guys a few questions that you need to do. So you flip to the MCQ, you have number 5, number 11, okay, number 30, okay, 74, 78, 79. Okay, and last one would be 86. Okay, so just a couple of MCQ. Help me to try them. Okay, once you're done, let's go through your transition elements. So when it comes to your transition elements, they are actually in the middle of your periodic table. You'll realize that they have no direct group numbers above them. Okay, but that will change in the future. Okay, next will be the more important points, so I'll highlight them in red. Is that transition elements tend to have multiple oxidation states. So you can see like your iron, right? You have 2+ and 3+. Okay, these transition elements also tend to form colored compounds, such as your blue copper 2 sulfate. Okay, so if you still recall your QA, this will be green, and this will be reddish brown. Okay, they will also be used as catalysts for reaction. So what do catalysts do? Catalyst helps to speed up reactions. Okay, but they themselves remain unchanged. Means they don't get reacted away. Other than that, these metals, right? Okay, transition elements are mostly metals. They tend to have very high density and high melting point, right? When I say that, it means higher density and high melting boiling point than the other metals. Okay. So if you're okay, let me show you which questions to try. Okay, help me to try the 2 open-ended question here. This is on page 15 and page 16. Okay. So once you're done, let's go back. Let's go through the halogens. So now when it comes to group 7, you have your halogens. So halogens are what attracts electrons to form an ion, right? They very specifically, right, will attract 1 electron. Okay, so all halogens will attract 1 electron. And their color will darken down the group. Okay, so if you go from F2, Cl2, Br2 to I2, they all have their different colors. So F2 will be pale yellow, Cl2 will be greenish yellow, okay, and Br2 will be a reddish brown. Okay, and then your I2, it depends on the state. So if it's a gas, you will see purple vapor. Okay, if it's solid, it will be a black crystal. Okay, so other than that, right, I just need you to know that what I'm going to write in purple is their state symbols at solid state. Okay, I2, it really depends. Mostly it will be a crystal, but sometimes if you evaporate it, it becomes a gas. Okay, oh sorry, it's a solid, not liquid. Okay. Okay, so moving on from here, the melting and boiling point will actually increase as you go lower into the group. Why? Because the intermolecular forces get stronger. Okay, so the next part here, okay, reactivity of the halogens actually decrease down the group. So why is that the case? Okay, so the reasoning, if you can follow on the right. First, your number of shells will increase. So that means your valence electrons becomes further away from your nucleus. and therefore it will experience weaker attractive forces between the nucleus and the electrons, and because of that, it will be harder to attract another electron for any reactions. Okay, so just take note of that. Okay, other than that, when it comes to your displacement reaction, okay, it's very similar to that of your metal. So a more reactive halogen will displace a less reactive halogen. So F2 and Br2, right? So F will actually displace Br2. Okay, right, so just take note of the coloring. Okay, so for these two compounds here, they will actually be colorless. So you don't really see much, but when it comes to bromine, you will know that he is reddish brown. Okay, so the observation here is that your colorless solution, alright, will turn brown. Okay, and the explanation is that the more reactive fluorine, right, displaces. Okay, so maybe if I were to spell it out, okay, displaces bromine from NaBr to form NaF and Br2. Okay. Okay, so once you guys are done, let me show you guys which questions to try. Okay, so there's a couple of MCQ that I want you guys to try also. So it's a mixture of halogens and your transition elements. So you can do 23, 54, 55, okay, 65, and 70. Okay, once you have done the MCQ, you can flip behind and help me to try this question here on page 17. Okay, and once you are done, let's go to your group 1 metals. So when it comes to your group 1 metals, we actually call them alkali metals. Why? Because they are too reactive. So we'll store them in oil. So the purpose of storing them in oil is to prevent exposure to oxygen and water. Okay, so these alkali metals will form ions of +1, so that means they need to lose 1 electron. Alright, other than that, maybe some key features you need to note about them, alright, is that they tend to be rather soft, alright, and they have low density, right, so they can be cut easily. Okay. So next is that their reactivity increases down the group, so this is the opposite of your halogens. So the reasoning is exactly the same, so you can see as your number of electron shells increases, the valence electron is further away from the nucleus, it experiences weaker attraction, and it becomes easier to lose electrons. Okay. Other than that, you need to know the reaction that alkali metals will have with water. So you can see that generally when they react with water, they will produce NaOH, okay, or basically a alkaline solution. Okay, there's another example here for potassium. You realize these two that I've circled here are your basic solution, your alkaline solution. Okay, the next thing here is your hydrogen, H2. So you will notice that these will be responsible for the effervescence. Okay, but you will notice here that K is actually more reactive. So if K is more reactive, what do you need to do is to be, exaggerate your reaction a little bit more, right? So you can see that it will burst into flames. Okay. Alright, so if you're okay, then that's more or less it for the content. There are a couple of questions that I need you to try, so you can flip all the way behind. Okay, you can do this one first. Okay, this is on page 19 and page 20. Okay. Alright, once you have done that, then the rest of the questions here, you can also do 21. 21 first, then after that you can finish up this one. This is on page 18. Okay, then only if you have more time, then you can try the last question over here on 22. Okay, if not, then that's all I have for you guys for today.